I'm James Campbell.
I'm a sculptor, and I've sort of come here tonight to talk a little bit about language and the kind of structure that goes into language in sculpture, and some of my influences and some of the things that have sort of aided the language in my sort of sculpture and helped me sort of make that exist as far as it is now. I'm kind of going to start with a sculptor that I was very interested in and still am very interested in, called David Smith. And he was making sculpture in the 1950s, but in the 60s he really kind of started making some very interesting work where he took steel. He started as a welder in a car factory outside of New York, and he moved on to making sculpture through knowing how to weld, and he brought steel sculpture together as a sculptural language. He was one of the first sort of abstract steel sculptors. He's an American, and I got this image here on the computer because I really like it. It expresses in like a two-dimensional way how someone can go about judging structure by a negative space. He would basically put pieces of scrap metal onto these canvases and spray over it with aerosol spray cans to sort of get a negative of basically what he would then go on to make in steel. And these structures, these sculptures that he made really pushed steel to a different degree of use. It's sort of, as well as in its nature, when you weld things together, things really hold. You don't have to have much of a joint to go on. So you could see here, he really managed to make things float. He manages to sort of move structure, the abilities of using the abilities of the material to create this language that he spoke with. In the workshop, he would lay things on the floor and put things together on the floor with a stick welder, and then stand them upright to create these pieces. But what he was doing for me was very influential, because I picked up some skills very early on in welding before I went to art school in an apprenticeship, and my interest sort of lay in this sort of form of this versatile form of joining materials together. Now, this is an artist that really influenced me. What I do in my work is kind of knife edge between sculpture and engineering. An engineer that's really influenced my work is R.G. Letourneau, and he was a Texan engineer in the 1920s to the 1970s that developed a number of machines which were kind of prototypes and also not really seen as being of any use. He was basically a prototype builder. Some of these, this one here is a snow buggy, and it's to pull sleds out to the ice caps for the American Army's research division. But he made a number of things which really influenced the earth-moving industry. He sort of went through all of the different kinds of earth-moving machinery in a marketplace which didn't need it, and then 20 years on, people started making these machines. They took a lot of influence off of him, but at the time he was kind of running a sort of liquidating company constantly, investing money into things which never really had a marketplace. One thing that he did invent was the electric wheel motor that we all know today is like the hybrid car. So a hybrid car is basically an engine, a gearbox and an electric motor that's between where the clutch would be, to sort of bring down sort of emissions and make the engine run at far lower revs. and he was developing things like that way back in the 20s. So he's a very interesting engineer for me. And the structures that he then went on to making in steel, very much like Smith being an artist and this guy being an engineer though. He was doing things with steel that not many engineers were doing. This is the kind of thing that we would see in ships and stuff, but he was putting that onto land vehicles. This is a what they call a jungle crusher, which is a really strange piece of equipment, and a lot of them went out to Vietnam. The ethics in his work was kind of not. Some things were great and other things were different. He really moved on a lot of engineering and stuff in earth-moving equipment, but at the same time he slowed a lot of things down, I guess, in the outside world. And this is again like this is what I call an orange peel grapple in the industry now. They're used in scrap handling and you may see them in scrapyards, but this is just an extreme kind of image of, it's as far as he got in sort of experimenting with his ideas. It's a machine which is completely useless, basically, in industry. There's no purpose for it, but he had to make it to sort of get the idea there to see how it would work. This is before like CAD modelling and computers and so on. And this is like, with David Smith, these structures, this one in particular, really have influenced sort of a language in the way that I go about in the workshop making my stuff. He also made these jack-up oil platforms, which are in the 50s when this one was made. It was seen as the industry kind of looked at him as a laughing stock. It was a 4,000-ton platform which basically lifts itself out the sea and starts a complete drilling derrick, and a drilling operation can commence within like 2 weeks. So it's much faster than standard sort of towers and subsea jackets and so on. It's like a big 4,000-ton mosquito for the Gulf of Mexico, which completely revolutionised offshore oil drilling. And then the company still exists today, and that's what they basically produce. So with all of the knowledge and the things that they learned from what he was developing when he was about, they took the best of what he'd done, all of the prototypes that he'd made, the best of which were the offshore platforms. And this one's 2001, and this is what they use in the Gulf now. It's a 32,000-ton jack-up platform. And this is it getting made. It's unbelievable that these things can even float with the sheer size and tonnage of them, but and also lift themselves out of the water using these legs. These legs will go down and then hit the sea bed, and the platform will come out of the water. The platform's a bit like a barge, and these legs will just lift it out of the water, and it's ready away from the swell, the ocean waves, and it's a stable drilling platform. But what leads me on to sort of other influences in this world of mining and offshore is a lot of the machines I've been making recently. I've been very interested in sort of walking and mechanisms of making equipment or things that I use in installation, which I'll get on to show you. Walk for their mark making purposes, and also their ability to move over different terrain. The first of the walking machines to be employed in industry are drag lines. A walking drag line is basically a machine employed in open cast mining for excavating the spoil off of the coal. It sits on big flippers basically. It has two of these either side of its chassis, and it tends to walk backwards, being that the arm's coming out this way. You can see that these amazing marks that it leaves underneath it almost sort of polishes the earth under compaction, and these sort of weird flipper footsteps that it leaves all around the place. that's kind of to show like a scale of the machine. The reason that they put them on feet in the first place was because they weigh so much that the crawler tracks and tyres would buckle, so that the feet are a structural part of their chassis. And then there's the size of the scoop or the bucket, which you could park a couple of cars in. It kind of goes on to the other end of the coin, though. The smaller you can get with walking machines, and these machines were made in the 80s by some scientists in America, in the States. They're two different machines. I'm very interested in the leg. The leg basically has a vein of 12 pipes in it, and the pipes have air put into them, and that makes the leg move in a very organic way. And you can see one model here that's walking down this person's finger is a mammal type leg, and then this leg design here is more of a reptile type leg, so they kind of go from opposite sides rather than a sort of walking motion. Though it's six-legged, and the six-leg design on these more contemporary walking machines has gone on to 2000 now, where Timberjack, a Scandinavian firm which make forestry equipment for tree harvesting and general forest care and so on for the forest industry, have decided to put a tree harvester on the chassis which incorporates these legs. And this, for me, right now, rather than this stuff happening back in the 50s with Letourneau and David Smith, is very influential to where my work is at the moment. This is the chassis of the machine with the legs. So this here is tread toe. I made this in 2010, and it basically it walks. It punts itself across the field using this centre telescopic arm and foot, and what it will leave behind it is this sort of crude footprint, a bit like the walking dragline and a bit like the Timberjack tree harvester. It runs on a hydraulic system, and it has I operate them, I drive them, so it's kind of like in the installation it becomes a bit like a performance. It also becomes an installation with the land around it marked and the machine in that. So it can be a static piece and also a moving piece. But in the progression of this, I've also been developing models for other machines which walk. And I have this method which I remember from school. I did it in primary school. We were given some syringes and some pipe to make hydraulic systems, basically. So this syringe has water in it. When that's pushed in, it will push the other syringe inside the machine out, and that little machine will walk along the plaster block or scrape along the plaster block in like a kind of caterpillar type contraction way, leaving marks on the block. And so I've been doing a lot of modelling like this. It's kind of like the old school R.G. Letourneau style modelling rather than the computer-based stuff. A lot of the computer-based stuff learns whilst you do things, but it doesn't know as much about this kind of movement and the weight to ratio to locomotion to traction. It's not as confident with. And then that's the finished machine, so it would be called telechassis, and that would be a machine a lot like tread toe that would leave a little bit more of an aggressive mark, has a far better steering capability, and has been learnt from this model here. So yeah, that's back to the beginning, but that's basically it. So,